Hi everybody, I'm back with another how to do it kind of video for you. This one's going to be on finding percent composition, or as it sometimes is called, finding the mass percent of a compound. We did this in class, but in case you didn't quite get it, or you just were absent, or you wanted to go through it again, I've prepared a little slideshow for you to go through it one more time. So percentages, of course, you know, you've been doing percentages most of your school time. It's taught very early, and it's always been done the exact same way. Percentages have never changed. You take the part that you're interested in, divide it by the whole, and then multiply by 100, and that's what gives you the percentage. So if we look at this collection of shirts that I have found here on the internet, we have a total of 15 shirts, if you count them all up there. If I ask what percentage of these shirts is yellow, you know that's a very simple thing to do. You just count up how many yellow ones. I see 1, 2, 3, 4 yellow ones. And you divide by the total number of shirts. There are 15 shirts there. So if I take 4 shirts divided by the 15 shirts, or the 4 yellow ones divided by the 15 shirts, multiply by 100, that gives me about 27%. I'm not being worried about sig figs there, because all I'm doing is counting numbers, and sig figs don't really matter when you're just doing counts. Okay, so the same thing can be applied to molecules, formula units. If we're talking about ionic compounds, you're going to do the same thing, and we're going to get the mass percent of the compound. So let's say we take this wonderful picture here of a aspirin molecule. If you take regular old baby aspirin, this is the molecule that you are consuming that helps take away your headache. In the model we have here, the black ones are your carbons, the reds are the oxygen, and hydrogen are the whites. And if you'll look and count, you'll see that there are 9 carbons, there are 8 hydrogens, and 4 oxygens. So if I want to know the percentage of, for instance, carbon in this compound, the first thing I'm going to do is go about finding the molecular mass. This one is a molecule, so I can call it molecular mass. And that will become what we call our whole. And so, since there are 9 carbon atoms, you multiply by the 1201, that gives you 108.09. 8 hydrogens times 1.01 gives you 8.08. And then 4 oxygen atoms times 16 apiece is 64. You add all those numbers up and you get a grand total of 180.17 grams per mole. So this becomes our whole. This is the overall molecular mass of this compound. If I want to know the part, say I want to know the percentage of carbon then in this compound, then I'm going to have to take the entirety of the carbon, which is 9 molecules times 1201, or the 108.09, and divide that by the entire molecular mass. So if we look at all of them here, we know that the carbon makes up 108.09 grams, the hydrogen is 8.08 grams, and the oxygen is 64 grams. These become the part in our formula, part divided by whole. So if I'm going then to calculate the percentage of carbon in this compound, I would take this part of carbon, 108.09, divide it by the whole mass, 180.17, and then multiply by 100. 108.09 divided by 180.17 times 100 would give me a 59.993% carbon. Notice here that I've got 5 sig figs to work with, because the 108.09 is 5, as is the bottom one, the 180.17. If I want to know the percentage of hydrogen, then I would take the 8.08 and divide it by the 180.17. It is worth noting that if I'm doing the percentage of the hydrogen, then I will only have 3 sig figs in my answer, because there are only 3 sig figs in that hydrogen mass. And I would have 4 sig figs in the oxygen. So I leave that as an exercise to you if you want to go back and calculate what is the percentage of hydrogen, what is the percentage of oxygen. But you would do each one the same way. You take this number divided by the total. So, here's a little challenge for you. If you want to pause this video while you do this, then you can check it at the end. Find the percentages of the sulfur, the percentage of sulfur in each one of these compounds. And so I've done each one. I've covered them up. Like I said, you can pause it and try and do those real quick. And then when you hit play again, you'll continue on with this video and it will go through the answers for you. So the answers end up looking like this. In the compound sodium sulfate, there are 142.05 grams per mole. There's only one sulfur per molecule or formula unit, and so that's 32.07. If I take 3207 divided by the 142.05 and then multiply by 100, I get 22.58. For the sodium thiosulfate, this is sodium thiosulfate is the name of this compound. Here we have a molecular mass of 158.12, but this time we have two sulfurs per molecule, so we have a 64.14 is the part. Divide those through and you get 40.56. And then here I've shown aluminum sulfate. In this you're going to have three sulfurs in each one of these formulas units. The molecular mass is the big one, is 342.17. The sulfur would be 3 times the 32.07, which is 9621. And then you divide that through and you get a 28.12%. Hopefully you got those all right. If you did, you're rocking on this one, and you probably don't need any more help, but should you need it, come in and see me during Power Hour or before school, and I'd be happy to go through some more examples with you. Talk to you later.